But you can't see the three-dimensionality of it, which brings us to the next topic, which is 2D waves versus 3D waves.
Yeah.
You want to talk about that?
Absolutely. This is the thing that this is why I'm so excited to do the show today. So there's what is that from the website?
So there's a guy on YouTube, and his YouTube's called Action Labs.
Yeah.
And I forget his name, but he's a really cool dude.
Yeah. So I've talked to McCain a bunch of times about how this stuff works, trying to understand it. And this thing that you showed me was like a breakthrough moment. I was like, oh, that's how you can pull stuff together.
Mm-hmm.
So it shows that the waves in the water take this ping pong ball and somehow magically, not magically, but obviously physics, it moves backwards.
So why don't you set up the audience for the actual experiment in normal mode? So in Actions Labs, he's got a basin of water.
Right.
And there's a metal ring hooked to a piece of foam in the water. And there's a ping pong ball in the water, and he has an oscillator on the top, which then makes the foam go up and down. And as he's doing that, the ping pong ball is being pushed away from the foam because the waves in the water are pushing it away.
The way that they overlap is pushing them away.
Yeah. But when he turns up the amplitude of the oscillator and then the ring starts like bouncing the foam really high up and down in the water, there's a new wave that appears. It's not a 2D wave where it's just going out like this, propagating this way, but it's actually propagating up and down now in the water. And then what happens next, Jason?
The ball somehow manages to get pulled back
towards the foam.
Yeah.
That is oscillating.
Yeah.
Which is totally counter.
It falls like into it. That's what made me kind of understand the idea behind the well. I was like, wait a minute. Okay, now it all makes sense. If the waves are going in such a way that the ball, the particle,
the electron
or atom
positron or whatever,
what would otherwise be getting pushed away or forced out gets basically pulled in,
sucked in.
Yeah. But
it's just a wave.
Well, I guess it kind of makes sense though that everything can kind of get bunched up into one spot.
Mm-hmm.
That's the well, right?
Yeah.
And then because everything's trying to get into a smaller and smaller and smaller spot, that's what basically like overcomes the Coulomb barrier, right?
Yeah. It's so essentially is the waves from the outside, they compress in on all directions, kind of like a cavitating bubble, and it compresses them all in with a basically negative wave. Because when you have a 2D wave, it just does a not longitudinal, but transverse waves like this on like an ocean. But if you have a 3D wave, you actually get a compression. You get a longitudinal wave in the wave. So you can have this transverse, but you can also have longitudinal waves in the water too.
And that kind of just like keeps crunching it. It's the
big crunch, like the quantum bounce phenomenon of the universe.
Cue the video.
I love that video.
Should we do a dance video sometime? Maybe?
You guys should check out the new merch for the Quantum Bounce music video, and we'll put it up here for you to check it out. But it's really awesome. Go ahead and get your stuff.
It's a fun song. I love it. I every time it comes by, I'm always like, oh, I'm gonna listen to it one more time. No, it's awesome. I mean, it's that video, that example was for me a breakthrough moment, because I was like, oh, I get why he calls it a well.
Yes.
I get why it pulls stuff together